This is the beginning of 7.2, rational exponents, and you're like, rational, oh my god, I have to work with fractions. Not too bad. When you have a radical and the radicand here, the radicand, remember, everything has an exponent of 1, so this really is a to the first power. Think of this as like a fraction in a way. So every radical can be rewritten using rational exponents. So this is a to the first, and then your index becomes the denominator of your fraction. So for example, if I wanted you to write stuff in exponential form, if I have the square root of 5 here, remember that this right here has an exponent of 1, so it's 5 to the 1. 1 is your numerator. And then this really has an index of 2, so this is 5 to the 1/2 power. Okay, same thing over here. We have the fourth root of 17xy. That means that this entire thing is being raised to the first power. Yes, every single one of these are raised to the 1 power, and you could write this with every single one of them raised to the first power. But since the entire thing is raised to the first power, we can rewrite that as the quantity of 17xy. And again, the entire thing is being raised to the first power, so that's why we have the 1 here. And because our index was 4 here, that's why our denominator is 4 here. Okay, so again, the denominator will tell you what your index is, and you get that from right there. Now, if I wanted you to go backwards and write stuff that was in radical form, or write stuff that was in exponential form into radical form, so we have 25 to the 1/2 power. That means that 25 is being raised to the 1 power, and this is a radical of 2, or a square root of 2. So this is how we would rewrite it into radical form. So exponential form, radical form. Again, the 25 is being raised to the first power. The denominator here was telling us that we had a radical, or a root of 2. And this is telling us the square root of 25, and that would be 5. Okay, so if you can actually do the operation, make sure that you do it. So this is saying the square root of 25. We know what that is, so we can take that as being 5. Next here, I have the quantity 12x to the third, y to the second, raised to the 1/7 power. Okay, so that means that when I stick this entire quantity here back into a radical, that means everything's going to stay the same way it is, because this is being raised to the first power. So this will stay as 12 to the first power, this will stay as x to the third, and this is y to the second. But when I stick it inside of a radical, I have to use an index of 7. So when I stick it into radical form, this is what we get here. Again, everything stayed the same. The 12, the x, the y, all stayed the same. It's just that it's being taken to the 7th root. Now, being able to change our exponents into fractions is helpful when we have something like this. We have the 5th root of x to the 20th power. So again, this is going to be our numerator of our fraction, and this is going to be our denominator. So I can rewrite it as such. Okay, so I get x to the 20 divided by 5, and that will reduce down to x to the 4th power. So again, knowing that our radical really can be changed into a fraction is very helpful here for us reducing or simplifying our work. Okay, so for example right here, we have the cubic root of r raised to the 21st power. Now, we need to rewrite our cubic root as a rational exponent. So this is really being raised to the first power, so this is going to become r to the 1/3 power as such. Now again, remember, we didn't do anything to the 21 that was on the outside, so therefore we have to leave the 21 on the outside here. So remember our rules of exponents from 090, that anytime you have an exponent being raised to another exponent, these are going to be multiplied together. So technically this is what it means. I have r to the 1/3 power times 21 over 1, because remember we can write that as a fraction. We can cross cancel, and then that will give us r to the 7th. So again, making sure that you follow the rules, changing your radicals into fractions, using your rules of exponents to simplify, and change that to r to the 7th. So sometimes we will get something like this. We have m to the 3/5 power. We need to change that into a radical form. So remember, the 3 is going to stay with the m, and the 5 is going to be our index number. So I can rewrite that as such. So m to the 3rd stays inside, raised to the 5th power, or to the 5th root here. Now, this also can be written like this. So remember on this one right here, how the 21 was on the outside, we can also write the 3 on the outside. Okay? Because, again, this is going to be to the 1/5 power times the 3/1, so it's still going to give us the 3/5 that we started off with. Either one of these are correct. I would probably just stick with the first one, being a little bit easier to write out. It's completely up to you, but either or should be correct. As long as you use parentheses when this is being raised to the 3rd power, you're good to go. Okay, so another example here where I have the quantity 5AB raised to the 7/4 power. So that means the 7 is going to stay with this quantity right here, and the 4 is going to be the index. So we see right here the 4 is the index, and the 7 is going to stay with the quantity 5AB. As we mentioned before, that can also be written like this, but I would just go ahead and stick with this one, probably the easiest one to do. Okay, if I ask you to simplify 36 raised to the 3/2 power, we can rewrite this into radical form 2 different ways. We talked about this just before this. So I can take 36 to the 3rd power inside with a radical of 2, or I could do that the very opposite way and do it like this. So the square root of 36 raised to the 3rd power. Now both are correct. Sorry about the glare. Both are correct, but if we look at this, one is a little bit easier than the other because I really don't want to take 36 to the 3rd power. Yes, we do have a calculator that would do that for us, but for sake of not using a calculator, this would probably be a little bit, this one right here would probably be a little bit easier because 36 is a perfect square. The square root of 36 is 6, and then I would have to raise that to the 3rd power. And 6 raised to the 3rd power is 216. Okay, so either one would be correct, but just looking at it, this one over here onto the right hand side would probably be a little bit easier to do, a little bit quicker to do. But again, you do it whichever way you feel comfortable, and we're good. Okay, next we're going to evaluate this. So that's 27 raised to the negative 2/3 power. Now remember, your rules of exponents, this is going to be all, this whole section is going to be reliant on your rules of exponents and your knowledge about those. Anytime we have a negative exponent, that means to take the inverse, which means that this is really 27 over 1. If I invert that, I'm going to get 1 over 27 raised to the positive 2/3 power. So remember, when we inverse that, it becomes a positive 2/3. Okay, so we use what we know about our exponential functions right here, and we rewrite this as such. So remember, our index is 3, and I would stick the 2 on the outside because, again, that's going to make this problem a lot easier to work with. So again, the 2 is on the outside of the entire thing, and our 3 is our index, which is our exponent or our root there. Okay, so if we look at this, we do what's inside the parentheses first. We take the cubic root of 27, which we know is 3, and that 3 is going to be raised to the 2nd power because, again, that 2 is on the outside here, and 3 squared is 9, so therefore our final answer is 1/9. Okay, so again, take the inverse, rewrite, and then start evaluating using your order of operations to get your final answer. Excuse me. Okay, here we have 36 over 49 raised to the negative 1/2 power. Now remember, again, if I have a negative exponent, that means to invert the entire fraction, so we get this. And so when we invert it, again, our exponent turns to a positive 1/2. Now when you have a fraction and something is being raised to an exponent, that means that each of these receive a 1/2 exponent. So that means I can rewrite it as such. So 49 to the 1/2 power and 36 to the 1/2 power. That technically means the square root of each, so the square root of 49 and the square root of 36, and we know that to be 7/6. Okay, here we need to start simplifying, so we have a lot going on. We have a negative on the inside and we have a negative on the outside of our quantity here. So the book will probably just have you go ahead and distribute that negative 1/2 all the way through. Again, one of the processes that I like to do is to get rid of negative exponents. I don't want to deal with them. So what I do is I try to get rid of them starting on the inside. So here I have a y to the -6th power. That means that this negative needs to come downstairs. So I need to actually write the y to the 6th power in the denominator as such here. Okay, so again, the negative exponent means for it to go downstairs, and I still have my negative 1/2 power here because this change right here did not do anything to this change here. Okay, so again, this is what we have right here. So 5x to the 4th divided by y to the 6th raised all to the negative 1/2 power. Again, this negative 1/2 power here means to invert it. So again, I'm going to flip this entire fraction and get this. So again, my denominator becomes my numerator becomes my denominator, and my exponent gets raised, gets changed to a positive 1/2 power. So this means that everything in the numerator receives a 1/2, and they're going to multiply. So this is going to multiply by this. This is going to multiply by the 1 that's right here. So this is going to multiply also the x to the 4th. So what we've done is I've shown you exactly that. So again, the 1/2 is going to multiply the exponent of 6/1. The 5 has an exponent of 1, so really that's just that's just going to become 5 to the 1/2 power. And then x to the 4th is going to multiply by the 1/2 also. So simplifying that, we get y to the 3rd power, because we use cross cancellation here. 5 to the 1/2 power can be rewritten as the square root of 5. And with cross cancellation here, we get x to the 2nd. Now be careful, if you end up writing your answer like this into my math lab, what could happen is when you enter the square root symbol here using the tools on my math lab, and you stick in 5, and then you try to stick in x to the 2nd, what's going to happen is that square root bar is going to go all the way across, and it's going to include x to the 2nd on the inside of the square root, so it's going to become part of the radicand, which is incorrect. So if you enter your answer like this into my math lab, please make sure that after you're done with the 5 that you hit the arrow, a right arrow, meaning that you are done with the radical, and that you want to enter x squared. Do not leave x squared inside of a radical. So again, hit that right arrow key to get outside of the radical to enter x squared. Now typically the radicands usually go last, because if we think of this as in descending order, this is really to the 1/2 power and this is to the 2nd power. So if it doesn't accept it written like this, you need to rewrite it like this, where the x squared is in front of the radical, because remember, radicals are to the 1/2 power, and we need to have this written in descending order. So usually everything that comes out of a radical or has a positive exponent or a whole number as an exponent needs to go first, and the radicals go last. So it's almost like our constant rule. Constants go last, radicals also go last. So this would be your answer for your simplifying. Okay, here I have 2.1x raised to the 1/4 power times a quantity 3.8 times 8 to the 1/2 power, sorry about that, and then plus x raised to the negative 1/6 power. So this becomes a distribution problem, so we have to take this and distribute to everything. So what's nice is the numbers will just multiply together, the decimals numbers will just multiply together, but we have to pay attention to our base x's here. So we're going to multiply x times x here. Remember, if we multiply like bases, we add the exponents. So we get this right here. Okay, so 7.98 x raised to the 1/4 plus 1/2. Now remember, I'm just taking the exponent that was here and adding it to the exponent that was here. Same thing with the exponent here, timesing this one right here. So I'm just rewriting it so that I'm focusing on just the exponents. Okay, so we have to find common denominators to do this. Remember, we have to have common denominators to add and subtract exponents, so I changed them. And then once we have common denominators, we can then simplify them down. So again, 1/4 plus 2/4 is 3/4, and 3/12 plus a negative 2/12 is a positive 1/12. And that will be our final answer. So when you're distributing, you multiply the numbers out front, but when it comes to your variables, you have to add the exponents. Okay, so again, we need to simplify this. We notice that we have two sets of z's. We have a z in the numerator and a z in the denominator, so we need to simplify that. But we also have a couple of negative exponents inside. So again, try to get those negatives dealt with up front if you want to. You don't have to. You could just go ahead and distribute that 1/4 on the outside here to every single one of these and then simplify. I just find it a little bit easier to simplify the negatives on the inside and then worry about on the outside. Technically, we are following order of operations. Order of operations says to do the parentheses first, which means simplify the inside first and then worry about the exponent on the outside. So that means that this x to the negative 2 needs to come down and the z to the negative 2/5 needs to come up. So we can rewrite it as such there. Okay, so again, the x squared came down, the z to the negative 2/5 came up. I can combine these two right here. So 3/5 plus 2/5 gives me 5/5, which means that this is just going to become z to the first power. So I can rewrite it like this. Okay, so that means that each of these are going to receive a 1/4 power, which can be rewritten like this. So 3 receives a 1/4 power, z receives a 1/4 power, and then x squared receives a 1/4 power, remembering that we are multiplying the exponents. That's why I have it written like this. I can then simplify that further down to 3 to the 1/4 power, z to the 1/4 power divided by x to the 1/2 power. Now because this problem was started in exponential form, it's okay to leave your answer in radical exponential form. So that is our final answer. Okay, here we're going to take some radicals and simplify them. So if your final answer cannot be written in an exponential form, since this started off as radical form, we need to make sure that we write this as a radical if possible. If it comes out to be perfect, there's no more radicals, then it's just whole numbers. So here we have the 16th root of 3y raised to the 4th power. So again, we can rewrite this using exponential form here. So we can reduce that fraction of 4/16 to 1/4. And since 1/4 is completely reduced, we can then rewrite it back into radical form. So that means that our index is 4 and 3y is being raised to the 1 power, or it is just itself. Okay. Next one here we have the cubic root of a, b to the 2nd, c to the 4th, all being raised to the 21st power. So that technically means that again this 3rd power is going to come out as such, and then that will reduce to the 7th power. And because there's no more radicals and we can do this operation, we can perform this, go ahead and distribute the 7 all the way through. So this becomes a to the 7th, b to the 14 because these two will multiply, and then this becomes c to the 28th because again those two will multiply, and then this is your final answer right here. And then next, we have two radicals inside of each other, so we have the cube root of the square root of x. Sounds a little bit weird. Okay, so we want to start on the inside and work our way out. So this right here becomes x to the 1/2 power, because remember there's a 2 up here. So it becomes like this. Now, with the cube root on the outside, technically that means that this would be divided by 3 again, but then that would become a complex fraction. It's just easier to think of this entire thing being raised to the 1 power. So then that will allow us to rewrite it as such, meaning that the entire thing can be raised to the 1/3 power. So you could, if you wanted to, do x to the 1/2 power divided by 3. But again, who really wants to look at something like that? If we were to rewrite this using what we know about division of dividing fractions, we could write this as 1/2 divided by 3/1. But we know that if we're dividing by a fraction, then we multiply by the reciprocal. So it would become this right here. So 1/2 times 1/3. This just looks really complicated to go through. So if you just think of this entire thing as being raised to the 1 power, then you can raise the entire thing to the 1/3 power. So here the 1/2 and the 1/3 multiply together to give us 1/6, and then since this is a radical here, or a rational here, we need to rewrite that as a radical. So this means that we have x to the 1st power. We don't need the 1 there, but it's there. And then our index is 6. So this would be the final answer right here. Okay, factoring expressions with rational exponents. Now this is going to be a little bit tough. Now before I showed you an example where we had to distribute an x that had an exponent that was a rational number. So then we have to go backwards. So if we distribute, we now have to know how to factor that out. And the best thing to know is to factor out the term with the smallest exponent. So whether that exponent be positive or negative, it needs to be the smallest. So for example, if I have x raised to the 3/7 power plus x raised to the negative 4/7 power, the smaller of the two is going to be x to the negative 4/7. That is what we need to factor out. Now one thing to remember, when we are factoring, we are actually dividing. Right? So if we are dividing, that means that we are subtracting exponents. Remember, when we divide like bases, we subtract the exponents. So I'm going to factor out an x to the negative 4/7. So that means that I have to go through and subtract 4/7, subtract a negative 4/7 to every single one of these. So I have to subtract a negative 4/7 from here, and I have to subtract a negative 4/7 from here. So when I write that out, this is what I have. So I have 3/7 minus a negative 4/7, and I have a negative 4/7 minus a negative 4/7. So remember that when we have double signs, that those double signs turn into positives. Both of them turn into positives. So that becomes a positive, that becomes a positive. And that this becomes a positive, and that becomes a positive. This does not become a positive. Remember, it's just the two that are right here. So I have 3/7 plus 4/7, which is 7/7. And when I do this, I get a negative 4/7 plus 4/7, which is 0. So I still have x to the negative 4/7 on the outside, because that's what I'm factoring out. But I need to simplify this. So I get x to the 7/7, which is technically 1, x to the 1 power, and anything raised to the 0 power is just a flat out 1. Okay, so this is what we get. Now, if you are writing this as your answer and sticking it into my math lab, it will count it wrong, because remember, we are not allowed to leave our answers with a negative exponent. So that means that we need to rewrite this by bringing that x to the negative 4/7 downstairs, which becomes a positive 4/7 down there. Okay? So remember, key thing is to factor out the smallest exponent first, and that will help you. And remember, you have to subtract that from every single one of them. We'll do another one. Okay, here's another one, x to the 1/4 minus x to the 5/4. So we see that the 1/4 is going to be smaller than the 5/4, so that's what we're going to factor out. And when we factor that out, remember that we have to subtract that from our exponents. So I'm subtracting 1/4 from 1/4, and I'm subtracting 1/4 from 5/4. So 1/4 from 1/4 is 0, and 1/4 from 5/4 is 4/4. So these need to be simplified. Anything to the 0 power is 1, and 4/4 is just 1. So therefore that is our final answer. So that one's an easier one. Let me do one more. I know that you guys like to see some different examples. So let's do when we have a negative exponent. Okay, here's another example when we have a negative exponent here. So again, we use the smallest of our exponents to factor out. So we're going to factor out a y to the negative 2/5. So that means I'm going to end up subtracting a negative 2/5 from each of these exponents. So I've rewritten it like this. So I factor out a y to the negative 2/5, and I am subtracting a negative 2/5 from each of these, which means that I have to pay attention to my signs. So these two become a positive, and these two will become a positive also. So we have a negative 2/5 plus 2/5, which is 0. And we have an 8/5 plus 2/5, which is 10/5. So we need to simplify those, and anything to the 0 power is 1. And this becomes y to the second power because 10 divided by 5 is 2. Now remember, we can't leave our answer like this because we have a negative exponent, so that needs to be moved down to the denominator as such, and that is your final answer.